Good morning. Today we are going to see circuit diagram for using NPN transistor as a switch. So I have taken out the components here in front of you. I have a breadboard, my power source, then one NPN transistor, two resistors. So one resistor I'm going to keep it at 1 kilo ohm, and the second one I'm going to keep it at 220 ohms. Yeah. So second one is 220 and an LED. You can select any given LED. I'm selecting blue color LED. I like blue color, so I have selected blue color LED. Now let us make the connection. Before making the connections, let us see what is a transistor is. You can see it has a collector, base and emitter, and this is an NPN. So this is negative, and this is positive. It's a type of NPN transistor. So let us make the connections and let us see. Concept wise, NPN transistors work in a way like it will connect between collector and emitter only when we provide some current on the base. So if we don't provide any current on the base, it will not make the connections between collector and emitter. So the circuit will not be complete. So let us see now how to make the connections. I hope you can see my screen. Now I'm making the connection. I'm taking first thing. I'll convert this. I'm connecting positive to the positive of the breadboard and negative to the negative of the breadboard. Negative I'll generally show it by black. Now once I make the connections, this is entirely positive and this entire line is negative. Now let us take our transistor. I'm placing the transistor here. So I have this as my collector, base and emitter. So this entire line is connected column wise. So this all holes are connected to collector, whereas these all holes are connected to emitter. Same goes for base. Now I'm taking a 1k resistor, that is 1 kilo ohm resistor. I'm placing it here. I'm going to rotate it and I want to connect it here with the collector. And other end of the resistor, as these all holes are connected now, I'll be taking and connecting to the negative of the battery or current source or voltage source, whatever you call it. This is to the negative. Okay. Now second again. Now I'm going to connect emitter. I have taken an LED. I'm going to place it here. Okay. This is cathode, this is anode. I need to switch this. So what I'm doing, I'm just using mirror function. So see, this has become anode and this has become cathode. If I click it again here, so you can see what is happening here. LED is switching the terminals. So this is for our convenience, we can do it in Tinkercad. So I'm keeping this as anode and this as cathode. Remember, this is NPN. So I'm connecting this end of the emitter with this and anode. I'm coloring it with, let's say, yellow. And again, now this is cathode. I'm connecting this to the negative of the voltage source. So you can say battery or a voltage source, whatever it is. Now my connections are ready. Now let us test the circuit. As you can see, when I test it out, I am providing 7.9. I can increase the voltage also. See, I am increasing the voltage. I am taking it to 30 volts, but you will not see my LED glowing because it is not getting connected between collector and emitter, as I have not provided any current on the base. So I am going to stop the simulation. Now I am going to take a resistor and place it in such a way that I can connect the base to the voltage source. So I'm placing my resistor here as all the terminals are connected. So through this 220 ohm resistor, I'm going to connect this end to the positive of the battery. Why positive? Remember NPN. So this is negative of the battery. This is also negative of the battery, and this will be positive of the battery P. Remember? So this is an NPN transistor. Now let us see what happens. Now see the circuit carefully. I've connected this with the voltage source, and here you can see my LED is glowing. I can, this exclamation mark shows that current rating is more than recommended. So what I am going to do, I can just reduce my voltage here. Yeah, so you see, so this is my NPN transistor as a switch. I hope you must have understood. You can tinker at your end. Thank you.